Module 5.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 5.1. How can we summarize categorical data? Once data has been collected, the next step is to look at the data to gain useful information. Saying something useful about raw data can be difficult, if not impossible. Suppose a veterinarian collects information from a sample of 25 dog owners who visit her clinic. For each dog, she collects breed, age at last birthday, weight in pounds, height to shoulder in inches of the dogs. The data are presented in the table below. Without doing any calculations, can you give a good description of the dogs at the office? Many data sets contain thousands of rows. Could you easily describe those data sets? One of the goals of this course is to be able to summarize a set of data. It's very difficult to look at a table of data and see what is happening. We need a set of tools to help us summarize the data into useful forms. In this module, we will look at ways to summarize data. These summaries are often referred to as descriptive biostatistics. It's important when describing data not to focus only on the calculations. You want to focus on what the calculated quantities tell you about the data. Your goal is to be able to tell a story with the data. The graphs and summary statistics aid you in telling that story. Before describing a data set, we need a set of vocabulary to help us talk about the data set. Definitions. The objects, people, or animals in the data set represents are known as cases. In the above example, the dogs are the cases. The characteristics of the cases are known as variables. In the above example, the variables are breed, age, sex, height, and weight. There are two ways we are going to classify variables. Categorical variable. Divides the cases into groups, places each into exactly one of two or more categories. In the above example, breed and sex are categorical variables. Categorical variables can take numeric values or non-numerical values where the values represent names or labels. Categorical variables can be subdivided into nominal variables. Have no intrinsic ordering to the category. Sex and breed are both nominal variables. Ordinal variables have a clear ordering to the categories. The dog data set does not have an ordinal variable. An example of an ordinal variable would be stress level, where the potential responses are low, medium, and high. Dichotomous variables only have two possible outcomes. Sex is a dichotomous variable. Note that nominal and ordinal variables can also be dichotomous. Quantitative variable measures a numerical quantity for each case. Numerical operations make sense for these variables. In the above example, age, height, and weight are quantitative variables. Caution. Often in data sets, categorical variables are labeled using numbers. For example, stress level could be recorded as 1 represents low, 2 represents medium, and 3 represents high. Just because a variable is recorded using numbers does not make it quantitative. How can we summarize categorical variable? Categorical variables are often summarized in a frequency table, which gives the counts in each category of a categorical variable. Example. Looking at the dog data on page 1 of the notes, we can summarize the categorical variable breed in a frequency table. We start by drawing a table with two columns. The first column will be breed, and the second column will be count or frequency of each breed. Next, we will list each of the breeds in the data set. Next, for each of the breeds, we want to count how many times each breed appears. Notice that Doberman appears 3 times in the data set. Therefore, we place a 3 next to Doberman. Your turn. Pause the video and finish the frequency table. When you restart the video, we'll look at the solution. You should have found the following frequencies. Your turn. Pause the video and use the space in the notes to create a frequency table for the variable sex. You should have found the following frequency table. An important summary statistic for describing a categorical variable is a proportion. A proportion can be calculated from categorical data when there are two options. It tells us out of the total how often one of the options occurs. Proportions will always be between 0 and 1. To calculate a proportion, the proportion is equal to the number in the category divided by the total. Example, looking at the dog data on page 1, we can summarize the categorical variable sex by looking at the proportion of dogs that are male. Notice that the proportion of male dogs is equal to the number of male dogs divided by the total number of dogs. Here, the two options are male or not male. So the proportion of male dogs for this data set is equal to 0.52. Notice here that sex was a dichotomous variable. We're not restricted to calculating portions for dichotomous variables. We could also look at the proportion for each of the breeds. The information in proportion can also be written as a percentage. We could say 52% of the dogs are male. Also notice that since 52% of the dogs are male, we know that 48% of the dogs are female. Or in other words, 48% of the dogs are not male. Your turn. Using the dataset on page 1, calculate the following. What proportion of the dogs are Dobermans? What proportion of the dogs are Labs? You should have found that the proportion of Dobermans is equal to 0.12. Notice here the two options in the numerator are Doberman or not Doberman. Looking at the table, we saw that 3 of the dogs were Dobermans out of a total of 25, giving us the proportion of 0.12. Similarly, the proportion of Labs is equal to 0.2. Proportions are also known as relative frequencies and can be displayed in a relative frequency table. Definitions. A frequency table is a table which looks at the count of units in each category of a categorical variable. A relative frequency table is a table which looks at the proportion of units in each category of a categorical variable. The relative frequencies will sum to 1. Example, looking at the dog data on page 1 of the notes, we can summarize the categorical variable breed in a relative frequency table. We start by drawing the table with two columns. The first column will be breed and the second column will be relative frequency or proportion of each breed. Next, we list the breeds in the data set. Next, for each of the breeds, we want to count how many times each breed appears. Notice that Doberman appears 3 times in the data set. Therefore, we place a 3 next to Doberman, then divide by the total number of dogs in the data set, resulting in a relative frequency or proportion of 0.12. Your turn. Pause the video and finish the frequency table. You should have found the following values. Your turn. Create a relative frequency table for the variable sex. You should have found the following relative frequency table. Notation for a proportion. We saw in a previous module that it's important to distinguish between a population and a sample. We will use notation to indicate if a proportion is calculated from a sample or a population. A proportion calculated from sample data is denoted as p hat and reads p hat. Notice that since p hat is calculated from sample data, it is a statistic. A proportion calculated from population data is denoted by the letter p. Notice that since p is calculated from population data, it is a parameter. Your turn. Read the following scenarios and decide if the proportion is calculated from sample data or population data, and give the correct notation and value. A. I want to know what percentage of teenage girls plan on going on a diet in the next month. I used an online poll and got 550 respondents. 32% of the respondents indicate they plan to start a diet in the next month. This proportion is calculated from sample data. Therefore, we have p hat is equal to 0.32. I want to know what proportion of Lexington City Council are in favor of a needle exchange program. I interview all of the members and find that 74% of them are in favor. This proportion is calculated from population data. Therefore, we have p is equal to 0.74. This concludes the Module 5.1 notes.